So I might be talking about things that many of you guys think are not real issues in networks like civils and right of way and digging up stuff. But at least I guess I've got my feet on the ground when it comes to network technology, so not up in the sky like you guys. I don't think this is my presentation. So I can definitely talk about the intensive, extensive information about the submarine cables around Africa, but it's definitely not my presentation. Can we get my presentation up, please? So I'm going to talk about LTE, and as you know, LTE stands for long-term evolution, and I guess the term is actually very descriptive about what the technology is. It is the evolution point between the existing current 2G, 3G technologies that we have, and very much the future vision that we have for wireless technologies with a 4G and even in the future one day 5G type of technologies. And that is exactly then what the evolution part is. It's an interim technology that probably will last the next 20 years. But let me go into that. So I'm going to talk about what's LTE, why do we need it, some of the requirements, some of the constraints, and then I'm going to focus, as requested, a bit on some of the real-world issues we experience in South Africa in rolling out the LTE network. So when we talk about what LTE is, that's exactly where I started off now. It's an evolution point between the current existing technologies and what we deem 4G. And I'm going to talk a little bit about this whole thing about what is LTE and what is 4G, because there's a lot of confusion in the market around that, mostly driven from a marketing perspective. It's defined to operate on a range of frequencies, which by itself also introduced a lot of problems in the different rollouts that we've seen around the globe and here in South Africa on TDD and FDD. It's a relatively high-speed network. For wireless, we're talking of speeds in excess of 150, 300 megabits per second, and it will grow over the next couple of decades probably into hundreds of megabits per second. I think it's very important to understand that LTE is very much today a complementary technology to the other access networks that we use, including satellite, fixed line, the current 2G and 3G networks, and so on. So just on this whole thing on what is a G, mostly when we talk about LTE, you hear people talk about 4G. Generations of networks were really a simple term coined a few decades ago to give us a transition between the original analog telephone systems, which were deemed generation 1 or the first generation, to the second generation, which were the first digital phones, the GSM phones. The cell phone, I think this year, turned 40 years. On the 3rd of April this year was the 40th anniversary of Dr. Martin Cooper making that first call. And that introduced two second-generation phones to us when we got the GSM technologies. That later got superseded by what the 3GPP called IMT 2000, which became known as the third generation. And you might remember there was a huge focus on 3G all over Europe. Licenses were sold for obscene amounts, to the point that operators to this day haven't recovered the costs that they paid for those licenses. And that was still okay. We had 1G, 2G, and 3G. And then, of course, the marketing people got hold of us. And every time there was incremental improvement in the technology, people tried to push the boundary on what the next generation is. But in IMT 2000, we had things like HSPA Plus, which is widely deployed in South Africa and around the globe. It's by far the dominant standard today. And that gives us speeds today practically up to about 42 megabits per second, and the specification can take us up to 168 megabits per second. And also in the 3G family, as the last evolution of the 3G family is LTE, long-term evolution. So a lot of people call it 3.9G, again, kind of like a marketing term to differentiate it from 3.7G. I mean, you are the nth generation of your family line. You're not the 3.9th generation. So these are really vague terms, and it confused a lot of people. 4G proper is something defined as IMT Advanced by the ITU, and there are two technologies in there. One is called LTE Advanced, and one is called Wireless MAN Advanced, and that's the evolution of WiMAX. Let me state it to you today. There are no 4G networks alive running in operation around the globe at all. 4G does not exist. It exists profusely in the mind of marketing people. So there was some confusion. The ITU defined 4G as IMT Advanced or LTE Advanced, which was the iteration that will come after LTE. And there are a few specifications of Lte Advanced, which is really, really interesting. The minimum speed, for example, when you do high mobility is 100 megabits per second. That's 100 megabits per second when you're doing 350 kilometers an hour. If you sit on a bullet train, you should be able to get access speeds of 100 megabits per second. When you're at slow speeds, pedestrian speeds, walking, in other words, talking on your cell phone, the specification is 1 gigabit per second. So you can think that kind of technology today just does not exist in a mobile form factor that you can carry around in a smartphone. The confusion all came in I think it was about December 2010 when the ITU put out a press statement that said, we call 4G Lte Advanced, but other people may call it something else. And that may, and that's the actual sentence on the board that they put in the press statement, that may got interpreted by a lot of people as an instruction. You now may call it an authorization. In long conversations with the ITU, I spoke to them at length trying to get them to actually retract the statement, but they left it there and people interpreted that word may as an indication that now the current 3G technologies that we have today, HSPA Plus and so on, and even LTE and WiMAX can be called 4G. So in South Africa, we've launched our LTE network as LTE, the 3GPP calls it LTE. A couple of operators around the globe call it LTE 4G, some only 4G. There were some attempts in South Africa to actually launch pure HSPA plus 3G technologies as 4G. And of course, look at any piece of equipment that you get from a vendor and it says 4G. So the vendors are driving this, and eventually I think we're just going to give up and everyone will call it 4G in the next couple of years. So LTE forms part of a roadmap, and this is the important thing. That's why these standards become so dominant. The 3GPP, which drive our LTE roadmap, have been very good over the last couple of decades to build roadmaps that move very, very smoothly. So we had a smooth migration path from 2G to 3G to the 3G technologies, HSPA Plus and so on, and LTE. So currently we're on 3GPP release 8, which is deployed on our networks and many other networks, and that gives us the LTE capability. There were other technology streams as well, which are now dying off. CDMA and EVDO and those technologies that were very popular up in Africa. Some networks in South Africa, it was popular in the US, but these things are all merging, and at the end of our LTE era, when we move into Lte Advanced, into proper LTE Advanced, proper 4G, these will all come together and we will see a merging of all these standards. So it's looking even better going forward. In terms of the performance you can get, there are two major factors that contribute throughput. The one is the efficiency, the spectral efficiency, and I'm going to talk about that. The other one is how much spectrum do you have, and of course antenna technology, as you guys will well know, is quite important. So if we look, for example, at a 2x5 megahertz with a single in, single out antenna, we get a maximum throughput or downlink speed of about 22 megabits per second, practically about 17 megabits per second. That's what you will get in this venue today. You'll get around about 16, 17 megabits per second on LTE. If you increase it to MIMO, where you've got multiple input-output antenna technologies, you can see the speeds jump up quite substantially. And that's actually what we've deployed now in most areas. So when we launch, we deploy to a single in, single out. Now we're there now. If you go to 2 times 10 megahertz, you can see what the speed is doing. It goes up to 85 megabits per second on the air interface, practically about 60, 70 megabits per second. That screenshot there was actually a practical screenshot I took the day we launched LTE, and that was on 2x10 MIMO, and I got 62 megabits per second. And that's quite astonishing if you think about it. On your device, in your hand, you can now carry technology that give you that kind of speed. So the spectral efficiency is the important bit in LTE. Well, there are a number of really important ones, but the spectral efficiency is really good. You can see here that at HSDPA, which is widely deployed today, we get 8 bits per second per hertz, which is a measure of spectral efficiency. LTE doubles that up to 16 bits per second per hertz. So we're squashing more and more bits into the same spectrum. There is a theoretical limit called Shannon's law, and we are approaching this law, but at this point in time, we are still getting improvements in it. So that 16 bits per second per hertz gives us at 10 megahertz approximately 150 megabits per second, and that's where you get the spec for LTE at 150 megabits per second. The other big thing for LTE is that it flattens the network architecture substantially. The architecture is simpler, there are less boxes, it's all IP. So we had a relatively complex 2G architecture and a complex 3G architecture. With LTE, it's becoming much simpler and it's flattening out quite a lot. Worldwide, LTE adoption is growing rapidly, and it will become the dominant technology over the next couple of years. We've already got 175 commercially launched networks around the globe. This was earlier this year, these numbers, with about 90 million subscribers. 400 plus operators have committed, but all the 3GPP operators, and that's the vast majority of them, will move into the LTE track over time. What's interesting is that because of the different frequencies that LTE can run on, some became dominant, and the one that actually ended up becoming dominant is 1800 megahertz. And you can see it here. If we look at the number of networks, that's 2600 there, and that is 1800 there. So 1800 is becoming the dominant frequency in which LTE is being deployed. It works quite well in areas where operators already have got 1800, and they can access that spectrum if they can't get access to new spectrum. You'll hear one word being repeated in this presentation many, many times today, and that is spectrum and the need for spectrum. It's the single biggest issue that we face. But 1800 megahertz today is becoming the dominant standard, and we see it in Africa. If we look from Angola to Namibia to Mauritius, people have deployed LTE on 1800 megahertz. In South Africa, we have deployed an 1800 megahertz, not by choice, but because we had no other choice to use our own spectrum, because we could not get access to some of the frequency available today in South Africa. MTN did the same. Cell C actually are deploying on 2100 megahertz. And Telkom sat on a nice fat piece of spectrum in I think they've got 60 megahertz and 2.3 gigahertz. So they've actually deployed a fixed line replacement service on that spectrum. But these different frequencies is problematic because devices will support a relatively small subset of them. You're not going to get an iPhone that supports 2.6 and 2.3 and 1.8 and 2.1. There'll be different models, so that becomes very problematic. And we can see that in the devices today that are running on the LTE networks, predominantly smartphones overtaking routers. So we can see LTE is already moving out of that fixed line replacement type of world like Lte deployed into a full mobile world. And the handsets today, all the top-end smartphones do support LTE and do support it at the frequencies we've deployed in South Africa. So the Nokia Lumia, the Apple iPhone, the Galaxy S3, all these devices support the relevant frequencies. So how long will LTE be with us? This is an interesting slide. I quite like this slide. It talks about from the initial deployment to peak volume in uptake, what's the lifespan of a technology? And it's interesting that we constantly get this 20-year lifespan. You know, we talk about our technology moves so fast and it rapidly evolves and it gets replaced all the time. I mean, we spend billions per year just refreshing our technology, yet these things live with us for a very, very long time. So we now, 2G is coming to the end of its life cycle. 3G has still got a lot to go up to 2020, we believe. And you can see 4G and then LTE, and again 4G in inverted commas, we believe will be with us for a very long time. Just to wrap up on what is LTE, this is a slide that I put up at a presentation in March 2011, 2 years ago. And the presentation asked, where are we with LTE? And I left the slide exactly as is. The short answer that I gave at that day, at that presentation, was we have to ask ICASA because we need the spectrum. The reality at that point in time is the networks were ready to launch. We had already done our trialing. MTN was at that point in trials. They were trialing their LTE network. Other operators already committed to rolling out LTE. WBS have got spectrum in 2.6. Neotel has got some spectrum. Cell C said they want to roll out, and ATA also indicated they want to roll out, and they've actually gone live now as well. There still are a lot of license holders in South Africa that would like to get access to spectrum to roll out services. But all of us, including the DOC or all parties, were waiting for what we call the digital migration, migrating to digital television so that we could free up 800 megahertz so that we can get access to that, because that's one of the frequencies we need. And we were waiting ICASA to allocate 2.6, which they've got a lot of, or they've handed out a lot of 2.6 to people like Centec and so on that never used it. And the call in ICASA and the DOC was to please take that spectrum back, allocate it to people that can actually roll out networks and build those networks. So this slide in 2011 stands today, and that is, in a sense, one of our challenges. The only thing that changed on this slide is that the mobile operators actually did roll out LTE. We had to reform and make plans to start rolling out LTE. But Struce, we are still waiting for the DOC and ICASA to allocate spectrum. And hopefully I don't put up a slide again in 2 years' time. Okay, so why do we need it? Well, you know, I guess for all the reasons we all understand. The biggest one is that on our networks, data is overtaking voice quite rapidly. We see a 60% year-on-year growth on data. Voice we see flattening out, and data is just running away. There's this exponential growth on the networks. And because voice is flattening, we actually see a decline in the revenue growth. So we've got this widening gap where revenue is flattening out and going negative, the growth rate in certain environments, and yet data is running away. And we need something to fill that gap. And that gap can only be filled by becoming more efficient. So that's where we spoke about things like spectral efficiency, flat IP networks, running our own transmission networks, our own fiber networks, and so on to try and close that gap down. And of course, as the network technologies increase, you invariably see new services with high demand coming about. So services like cloud-based services, where eventually everything will be in the cloud and you will have a permanent connection to the cloud, is becoming more and more important. Video services must be the big one that we will see in the future. We're already seeing attempts at this with services like Netflix and Hulu and Apple TV, and streaming video will just become more and more dominant. But the new social networks that we see that are being built just require more and more bandwidth. You don't upload a photo of what you ate to Facebook anymore. You start uploading a video of what you ate, and the video must be in high definition. I don't know if you've seen the work being done with wearable technology like Google Glass, where you wear glasses. Those things will stream data all the time. And where a typical user today might use 1 or 2 or 5 gigabytes of data in a month, we will be looking at 300, 400 gigabytes just in a normal user environment, not these people that download the internet every month. I saw in the news yesterday a guy in the UK clocked, a consumer clocked 77 terabytes of downloads in 1 month. In South Africa, we see on our fixed line networks over a terabyte easily, and on our network on Vodacom, we've seen 300 gigabytes of downloads in a month. That's clearly at the outlier level, but the point is the bandwidth is increasing, or the requirements are increasing. The other big thing that's a big driver for LTE is what we call the Internet of Things. As we have more and more devices that need to be interconnected to share information, you know, from all the different telemetry elements to the devices in your house, in your car, everything needs to be connected. And some of the projections talk about billions of devices over the next couple of years, in the next 2 decades. These things will all need some kind of wireless connection, and LTE, again, in the fact that it's a flat IP environment, is well suited to that. And of course, realistically, this has to be wireless, all these connections. So LTE is very, very well positioned. I guess the most important one from a consumer point of view in any case is that they want this instant gratification, they want instant satisfaction. None of us like clicking on a link or clicking on a movie or clicking on a song and then having to go and make a cup of coffee and wait for the thing to download. Customers will tolerate response times of seconds, and that's okay. Minutes become bad, and hours is just not the way we do things anymore. So if I want to download a high-def movie, I'm probably happy to wait for a few minutes and then at least it should start streaming. But I really want to be in this world where things happen in seconds. This world that is still dominant in so many environments where things happen in hours. You know, that's just not the way humans like to work. We want instant gratification. And that is one of the big drivers again for LTE. Okay, so we spoke a lot about this. What do we need? Spectrum. I'm going to say it again. Spectrum, spectrum, and spectrum. That's what we need. And not just a specific frequency. We've got different frequencies. If we look at 800 megahertz, it gives us a coverage of approximately 20 square kilometers. If we go all the way to 2.6 gigs, it only gives us 5.6 kilometers. So for a rural type of deployment, we do need the low frequencies where we can have big cells with towers far apart, with low population density that we can serve as well. We're inversely, in the urban areas, in a place like Sandton, we're probably better off with a very high frequency, 2.6 gig or 2.1 gig, where we can control the cells. You don't want massive, big overlapping cells with too many users per cell. That leads to quality issues, clearly. So we do need the correct frequency in the different areas, and that is why we're all screaming and hollering for 2.6 to be released to us and for 800 to be released to us. Both these frequencies are available or will be available soon, and we need it to roll out. And then, of course, that's the frequency in terms of what it gives you. Then you need a block of that frequency, and you need a contiguous block. You need a single solid block of that frequency. And the minimum you need for a proper service is at least 20 megahertz for what we have today. So you can see here as the the amount of allocation goes up, the speeds go up. So we need at least 20 megahertz. Some of the operators today sit with 15 megahertz of a certain block, and it's just not a logical way. So there's a huge requirement in ICASA to clean up the whole spectrum allocation. We clearly need lots of sites. If you are building towers 5 kilometers apart or 3 kilometers apart, then you need lots of sites. And that's a big challenge in South Africa, to try and get the sites up. And once we've got those sites, and it can easily take 3 years to get a specific site. Once we've got those sites, we need to get fiber to it. Clearly for the speeds we're talking about here, you can't backhaul this with normal copper, and microwave is too expensive. So if we can do fiber, we do fiber, and operators like ourselves and MTN and some of the others have been on very aggressive fiber rollout plans. We've got a lot of our towers already connected by fiber. At the core side, you need a new LTE core. You need a whole number of pieces of equipment in there that you probably didn't have before, things like IMS to do voice. You need proper OSS and BSS systems. You need new HLR technologies. You need new security technologies. There's a whole lot of stuff that needs to be done in the core before you can roll out an LTE. And then lastly, of course, you need a device. If you don't have a cell phone in your hand, what's the use of a service? And you need devices to be sexy and to be affordable. So today, price is still an issue. The high-end smartphones are still expensive, but they all do support LTE, and I'll show you a graph now of the uptake, and we're seeing a very rapid uptake of LTE now. Okay, so Vodacom, we were the first in the Vodafone group to launch, well, we were first in South Africa, sorry, we were the third in the Vodafone group. Germany launched before us. On a very much a fixed line replacement, but they had access to spectrum, and modems were available in those days. Handsets were not really available, followed by Portugal and then South Africa, and I think it was Romania launched at the same time. And we launched on 1800 megahertz. So our launch itself, we launched on the 10th of October last year. We were the first to launch in South Africa. Some of the other networks were trialing. We did our trials, I think, in 2010. So we were pretty much ready, but there were a few things that held us back from launching. The one was clearly spectrum. We were hoping to get spectrum from the regulator. The other one was devices. Without the handsets, you would end up just deploying modems, and it would be a very limited rollout for the capital investment you would make in this. And that timing came together around in about October, when we saw the first handsets coming out. The Samsung Galaxy S3 was the first one we brought into the country that supported LTE. Most important that we were the first to offer voice on an LTE network. It's not voice over LTE, but it's voice on an LTE network, which again, if you don't have voice, what's the use of having a handset? You want to make phone calls with this device. And that actually turned out to be one of the biggest challenges. I think a lot of the other operators, some of them that haven't launched today, are still battling to get that right. We managed to get that right, and it worked successfully from day one. So we had a couple of other firsts. We were the first to launch for iPhone 5. I'll show you what it did to the network uptake just now. The Galaxy S3, which was our launch phone with one or two other devices. The new BlackBerry Z10s. Nearly every smartphone now, the Nokia Lumia 920 and so on, they all support LTE now. Initially, we launched at a contract level, and that was purely because we were still doing some work at the OSS BSS level, and that was followed quite quickly by prepaid. So it's across all the services. So today, or at least when I did these slides, we had in excess of 200,000 customers already subscribed to the network, on the LTE network, which doesn't sound like a big number compared to some of the other operators, or to some of our other technologies. We're sitting with a base of over 20 million, as you know. But 200,000 in 6 months on a new technology that is a premium technology in terms of pricing is a very, very good uptake. And in a sense, it's the new smartphones that are driving that, the iPhone 5 especially. The important thing as well is we looked at how you commercialize this, and that's a big challenge. You know, we spent billions on rolling this thing out. How do you commercialize it? And the reality is consumers will not accept a price increase for new speeds. It's a tendency that we created over the years, that every time we upgraded the network, the service stayed the same price and typically went down. And as you know, we're currently in a price war in South Africa. So we on 3G, you paid 50, 70, 81 Rand per megabyte of data. On LTE today, you can pay as little as 7 cents. I think our best price currently is about 2 cents a megabyte on LTE on some of the promotions we're running. So today we've got 611 sites deployed. And here's the graph I spoke about earlier. This is when we launched. Those were modem sales. You can see slowly iPhone 5. It jumped the network overnight to tens of thousands of devices. Then it grew quite rapidly, and that is where we introduced prepaid as a service, and again, it took off. So you can see the growth rate is substantial on the network, so it's driven very much by the smartphones. In terms of performance, I spoke a little about those. These were some practical screenshots I took at launch time on my Galaxy S3 around this area. So 15 in Sandton City on CISO 5 megahertz, so getting 15 megabits per second, up to 67 megabits per second on MyMate 2 times 10 megahertz. And this is all on the same device. So as I move through the network, the phones automatically adapt to the technologies available and give us speeds. So you can see the speeds are really phenomenal. But of course, we've got a relatively limited rollout currently with 610 sites. So some of the constraints we had, again, the word spectrum is going to come up. We had to reform our own spectrum, and that is really, really not optimal. Our network is already loaded as it is, with the 1800 megahertz spectrum being used by our voice customers. We've got 26 million plus using that frequency. So we had to be very, very selective where we could take 5 megahertz or even 10 megahertz away from ourselves to help ourselves. So it is not the optimal solution. We really need to get the right spectrum from the regulator. We've got MIMO on all the sites now, so we get about 30 megabits per second on all sites, up to about 60, 65 megabits per second on the 2x10 sites where we do have those 2x10s. The important thing, though, is that we've got a big network. We've got currently about 10,000 towers out there. The bulk of them are on 3G, and the bulk of those are on what we call dual carrier, so they give very similar speeds. So what worked well for us is that we could offload some of our 3G requirements onto LTE, and customers will typically only see an improvement in performance, not a degradation, because of the limited spectrum. So on DC, you get up to 42 megabits per second. On LTE, on 5 megahertz, you also get 42 megabits per second. So it's a good it's a good experience all across the network. However, this is not an admission by the mobile operators that we don't need more spectrum. The regulator made a statement in the press about a week ago saying they can't understand why we need more spectrum. I really need to take her through this presentation because we really do need more spectrum. We're really hurting ourselves by doing this reforming. And I'll talk a little bit later on why are we doing it then. And one of those is to try and satisfy our government. Site selection. Site selection was the other one. We were fortunate there that we've got our own sites. We've got our own backhaul. Most of our sites are fiber connected. We had to do a lot of work clearly on the radio network, single RAN environments we had to roll out. We had to build those cores. There were some challenges there, but we got those challenges sorted out. We got the voice sorted out, which really was a big thing. It sounds like a trivial thing when I talk about it now, but the engineers were sweating in a room for a couple of weeks. On timing and rolling this out, from the time we decided to go to the time we went live with 70 sites on the 10th of October, 4 weeks. But that's due to very, very good planning on the side of engineering guys. So we had it ready, we couldn't go, we were waiting for the devices, we decided to go 4 weeks, we rolled out this network. It was quite an achievement, I believe. The devices were exactly timed to work with a launch, so literally I think the 8th or the 9th of October, the Samsung devices flew into the country that we needed for the launch. So it was a very tight program, and that was one of the successes, the way we managed the program. We will carry on doing this clearly. We will carry on rolling out. We're continuing with our fiber rollout. The core will be extended to include more elements. We keep on consolidating the backend systems, and we keep on introducing new things as we learn about IP. We're now in a proper IP world. It's not the old telco world anymore. We're in an IP world now. So that is a challenge for many people that come out of a traditional telco world, is this thing called IP with all the security issues it brings. The next step via something called IMS, which we've deployed in the network, is voice over LTE. We're waiting for the devices. We're ready to do that. That'll probably happen in the next couple of months. And we will clearly extend our offers. We'll build more and more fixed line replacement offers on the back of LTE as we get more spectrum to provide really high speed access into a fixed environment, 100 megabits per second plus. And there's a big drive into the enterprise and into the corporate world for it as well. I'm really not going to go through this slide. 3 main things. Get your program management right. That was the single biggest success factor, I believe, is that everyone worked together. And I know it's a cliche, and we always say we work together, but working across multiple vendors, multiple departments, within a 4-week time period of technology that's never been rolled out at this scale, that's never been tested. The devices were still in the air when we were building the network. It was a challenge, and we did it with very, very good program management. There's a lot of work that needs to be done in the core. We had a lot of problems there. Probably the single biggest lesson that we learned is that it was easier to roll out the network than the supporting BSS systems. getting the provisioning right, getting the billing right. Those were some of the big challenges. And most importantly, keep your customer care people involved. You know, they often the people at the end of the project that suddenly learn in the news, in the press, that there's a new service being rolled out. We did a fair amount of work to make sure that they understood the new technologies, the issues you were going to see in the handsets. When the iPhone 5 came out, it was an absolute nightmare. The software didn't work. People complained they were disconnected from the network. We went through 3 or 4 different versions of software before the iPhone started working properly. So just to wrap up then, LTE subscription is, and uptake is slow. It's on the back of the devices, still being premium devices, still 8,000 Rand type of handsets, but it is accelerating. The fragmented nature of a spectrum is really problematic. It's very problematic for the device vendors. If you roll out on 2.6 and other countries roll out on 1.8 and some people roll out on 2.3, who do you support? And the moment you support one, it tends to become dominant, and that's what happened with 1800. More people rolled out on 1800 because of refarming. Devices started supporting 1800, and now more and more people will have to roll out on 1800. So that fragmented nature of a spectrum is problematic, and you'll have to consider that. The spectrum availability, as we spoke about, we need these big blocks of spectrum. That is really, really a big issue. It's an expensive game. We spend billions on this, and we need to somehow recoup that investment, and that is the problem. How do you recoup investment on a technology when people aren't willing to pay for it? So those are just some of the challenges that will face any new operator. So my last slide. I think it's important to understand that LTE is both complementary and a substituting technology. It doesn't replace anything today. It will run in a heterogeneous type of environment, and we see it's got a very long life cycle. For a mobile operator, LTE is all sexy, but our bread and butter business is our 2G and our 3G voice networks, and we need to focus on those, and we clearly do focus on those, and especially the quality. It's nice to say to your buddies you've got 100 megabits per second download, but if you drop a call, you tend to talk more about that. It's not standalone for the interim. It's complex. It's a lot of changes in the organization, so be ready for that. Get those right building blocks in place. Make sure you've got single RAN. Make sure that you've got software-defined radios going into the future. Make sure you've got a proper IP core, and that will help you to actually roll out LTE. Pick the right partners. I assume there are a few vendors in the room. It's important to pick the right partners. Pick the right partners, and then these things will work. And then the last one, again, spectrum. It's scarce. Use it wisely. And make sure that you put pressure on the regulators. The mobile network operators, as I said, they are doing what they can to come around these severe constraints, and we have done what we can. But it really is now up to the DOC and the regulator to make sure that we get that spectrum. The minister last year said that by 2020, they want 100% broadband penetration in South Africa. 100% broadband penetration in a country this size. That's 7 years from now. The single biggest impeding factor that we have today is the Minister of Communications. Thank you very much.